For solving problems like these, where you're ranking relative solubility of different compounds in water and organic solvents, you can refer to your reference sheet that looks at intermolecular forces and how different kinds of functional groups are more soluble in different solvents. I did a video on this, and I have a reference sheet. I highly recommend you memorize this reference sheet, where you can look at something like C5H12 and say that is a nonpolar molecule. And so its intermolecular forces are going to be dispersion forces, and they are very weak. And you look at this, and you're told it's a carboxylic acid, and you can draw it. 4 carbons with a carboxylic acid, and you look and say, here is a hydrogen bonding. A hydrogen bonding group. And this is short, just a few carbons long, of a nonpolar chain, and so hydrogen bonding is the main thing going on there. So nonpolar molecules are going to dissolve in organic solvents like hexane best, and hydrogen bonding molecules are going to dissolve in hydrogen bonding solvents like water the best. And memorizing these functional groups so that you can look at a molecule and say, it has this intermolecular force. We can go to this next one. 8 carbons total. 1, 2, 3, 4, 5, 6, 7, 8. Carboxylic acid group. You can just look at it and say what kind of intermolecular force it has. We've got hydrogen bonds on this end. We've got nonpolar on this end. So this molecule, one end of it would like to dissolve in water, and one end of it in organic solvents. Let's look at the next one. And I'll start drawing it. But having these intermolecular forces memorized will allow you to understand a lot of things in biochemistry and biology, not only during this course, but beyond, into later courses and in your life. So it's a little bit of chemistry to memorize, and that can give you a lot of general understanding of chemistry whenever you encounter it in your life. So again, we have the nonpolar part. It's a little bit long. This isn't going to need, neither of these will be very soluble in water because of this 7 carbon nonpolar part, but then we've got an ionic part. The ionic part really doesn't want to be in a nonpolar solvent. The hydrogen bonding part doesn't want to be in a nonpolar solvent either, but it's not as big a difference between hydrogen bonding and nonpolar dispersion forces as it is between ionic and dispersion forces. That's a much bigger difference. So while neither of these will dissolve well in water, actually this one, this ionic one, will dissolve quite well in water. It will act like a soap. Whereas this carboxylic acid, relative to the soap, will dissolve better in an organic solvent.